Hi guys, in this video we're going to be looking at how we write a quadratic expression ax squared plus bx plus c in the form a times x plus b all squared plus c. Okay, now basically this form of a quadratic and this form, it's really the same thing, I mean they are equivalent, right? So in the exam we could be asked that question, or they could ask us to show that ax squared plus bx plus c plus bx plus c is equivalent, and these three strokes means equivalent to a open bracket x plus b all squared plus c. Okay, so these are two ways. So this is number one, they could ask us to show that, or number two, the question could ask in another way. Okay, I just want you to be familiar with any way that they ask the question, you know what to do. Okay, so we have been looking at quadratics that are perfect squares. Now we may be put in a situation where we are asked now to complete the square, where we are given quadratics that is not a perfect square and quadratics that may be it's a perfect square, and we're asked to complete the square. So just let's look at the concept behind it and how we deal with situations like that. Take for example, they gave us x squared plus 6x plus 5. Okay, and if you notice, this is in its general form, and now they are going to ask us to write it in the form a times x plus b all squared plus c. Okay, so I'm moving from this form to this form. This is pretty easy. First, before we calculate it, I am just going to show you the concept behind it, okay? And just work with me. Alright, this is the concept behind it. First, I am going to take the x squared, alright? And I'm going to say, since we're completing the square, I am going to draw my diagram. Okay, that's not good. Let me just try and get this quickly. Okay, so I have drawn my square. Okay, now, oops, let me just get rid of that. So that's my square. Okay guys, so what I'm saying, in this square, if you notice, this is a perfect square, right? So this is x times x would give me x squared. So what I'm saying here is that this side is x and that side is x, and we learned that in a square all sides have the same length. Okay, so x times x would give me x squared, which is this first term here. Now we would have learned earlier that when we're trying to find if a quadratic is a perfect square, we would take half of b, and in this case b is 6. So what I'm going to do here now, I am going to split this middle term into half. I'm going to divide it by 2. Okay, so I'm going to say this would give me 3x plus 3x, right? That's the same as 6. So what I'm doing here now, guys, to make this a bit easy, is that I'm taking half of b, which is half of 6, which is 3. So I am going to say this is 1, okay, 2, okay, and this would be 3 pieces. Okay, so we have here, we have a plus 3. So here now we have a plus 3. We have just added a half of this to this side, so now we must add the other half to the next side. So this is a half here, a half of b here added to that side, and I'm going to add my next half here. Okay, so I have 1, no, that's not good. So this is 1, good, that's 2, good, and that is 3. Okay, no, that's too big, and this would be 3. Okay, Okay, now guys, so what this basically is saying, I have now divided my b into 2, or I've taken half of b and I've added 3 to this side, and now I must also add 3 to this side. Okay, so this again is x plus 3. So this length here is x plus 3, this length here is x plus 3, and that length there is x plus 3. Okay, and it's a square, and we know that in a square all sides are of the same length, so also this length here is also x plus 3. Okay, and this is the whole concept behind completing the square. Now I've taken my x square, and as you have seen, I've distributed in the first, and this is the pink, rose pink square where both sides is x length, and then I have divided my b into 2. I've taken a half of it, which is the coefficient of x squared, and I've distributed 3 here and 3 here. So now for the final term here, to determine what value would I get for my 5 here. Now if you notice, we have basically 3 full squares here, but we have a part that is missing. So there is a part here that is subtracted from this square. To make this square complete, now we need to find out how many little boxes will make up this portion. Okay, so this missing piece, now we're going to have to figure that out. So this missing piece here would relate to this 5 here. So whatever I get for the whatever amount of square boxes I get for this little piece, I would have to subtract it from 5, because that is the amount that is missing. Okay, so let's figure that out. So to complete my square, I would have to make my little square boxes here, and all I'm going to do is to bring down these, bring down that. Okay, and all I'm doing now is to bring across this and bring across that. So here now I would have how many little boxes? 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. Okay, so to complete this, I would have to subtract 9 from my 5, because I got 9 square boxes. So in completing the square, I would have x plus 3, and if you notice, this length is x plus 3, that length is x plus 3, so my answer would be x plus 3 all squared, because this now is a perfect square. We have completed the square, and I'm saying 5 minus 9, and that would give me a -4. Okay, and that's my answer, and that's how we complete the square. It's that easy. Okay, all right, we'll look at some more activities in the next video. All right, thank you, bye.